It's 12:03. I'm sure we'll have some other folks joining us, but we'll get started. And just want to welcome you all and thank you for joining us today. Really excited to share this new curriculum, a changing Arctic ecosystem, with you all. It'll be the first ever workshop focused on this curriculum. And I want to just make mention of the fact right now that this curriculum is a draft. There will be modifications this fall made to this curriculum, including a couple of extension lessons that I'll reference. And I also want to make mention at the start here that we are going to be looking for piloting teachers for this curriculum. I think right now our plan is to have five teachers, hopefully get 5 teachers to pilot this curriculum, and we'll compensate educators with $200 for piloting the curriculum and providing feedback. Also want to mention before we get started that if you like what you see and you don't want to pilot, but you might facilitate this, we also have funds to purchase materials for you. And so just wanted to put that plug in at the start, knowing that, this curriculum, it's freely available. We'll go through it step by step today, but also want you to know that, I want you to continue to use me as a resource. And I want to continue to help you should you be interested in facilitating this, whether that's, one-on-one conversations, funds to buy materials, whatever it may be. So we'll just start with that. Also, again, appreciate your flexibility in this transition from a 2-day workshop to the 1-day workshop today. Just given the scope of this unit, I felt like it would be most engaging in 1 day. I didn't want to draw it out into 2 days. I know time is precious to everyone, myself included. And so I didn't want this to drag on for 2 days if it didn't need to. So I think we can get the hang of things in 1 day. Everybody who participates will receive a 4-hour professional development certificate. And those that are interested in completing a final assignment will get a 6-hour professional development certificate. So just wanted to start with some of that background information here. And also mention, we'll talk a lot more about this here in a moment, but this is a curriculum inspired by the Mosaic Arctic Research Expedition. Mosaic, this is a test, stands for the Multidisciplinary Drifting Observatory for the Study of the Arctic Climate. Pretty sure. So we'll talk a lot more about Mosaic. Those of you that have already engaged with Mosaic resources in the past, there might be a little bit of review there, but that's okay. Without further ado, I think it's time. This ends today at 2 p.m. Mountain Time. Without further ado, I'd first like to let some of my colleagues introduce themselves. I'll introduce myself, and we'll get going. Lynn, why don't you take over?
Sounds good. Thanks, John. Hi, everyone. It's so great to see familiar names and faces and also new names and faces. So welcome and thanks for joining us today. I'm Lynn Harden. I am a curriculum developer at the Cooperative Institute for Research and Environmental Sciences here at CU Boulder. And along with John, he and I co-led the US-based outreach efforts for the Mosaic expedition. So it's something that we feel really passionate about and I'm really excited to share with you. I'm a geologist by training, but I've been doing education and outreach for about a decade now. I've taught in the classroom and I've done curriculum development work and have been here at Ceres for about 2 years now. So I'm looking forward to working with you all today, and I'll be monitoring the chat. So if you have any questions at all about anything, feel free to throw them in the chat and I'll try to answer them as best as I can. So welcome.
Thanks, Lynn. That happens to be too often where the screen disappears. Daniela, would you mind introducing yourself?
Sure. Hi, everybody. Thanks, John. I'm so excited to be here. I am a new employee with Sears and just kind of joining the mix here. I have an environmental science background and similarly to Lynn, about a decade of experience working in education in various forms. So I'm excited for this and to join you all this morning. Thank you so much for having me.
Great, thanks, Daniela. And I wanted to make sure Daniela had a chance to introduce herself because those of you that are going to be working with us, whether it's in this unit or on other resources that we've developed, are sure to, those units are sure to have Daniela's fingerprints on them. And she's going to be working with us on all sorts of things, website related, curriculum development related, and maybe even some payment and processing tasks there. So wanted to have her introduce herself. I want to acknowledge our director, Anna Gald, who's been incredibly supportive of our work and gives us lots of creative freedom to do what we do best, which is develop curriculum. And also Byron Blomquist, who's a mosaic scientist whose funds and research is the inspiration behind this unit. I guess that said, my name is John Griffith. I know there are a lot of familiar faces here, but for those of you that don't already know me, I'm a former climate scientist. Spent a number of years in Alaska coring lakes and studying lake sediments to better understand past environments and climates. Transitioned into a middle school classroom and spent 5 years teaching 8th grade science in Flagstaff, Arizona. Chased my girlfriend to Denver, Colorado, and got this job at CU Boulder with Series. Kind of the best of both worlds, working with scientists to write curriculum and bring their work into middle school and high school classrooms, and have since moved to central Vermont. So got some neighbors here in Vermont and New Hampshire, but continue to work remotely in this position. Really excited to have you all here today. And want to just briefly go over a few things. Really excited to have you here. Please be engaged. Whether or not you have your video on now, it's kind of irrelevant, but we're going to be going back and forth between breakout rooms pretty frequently here today, and would encourage you to turn your cameras on when you're engaging with your colleagues, your peers in that space. I want to just skip down to this 4th bullet point here, and want to encourage you all to use the chat as much as possible, whether you're talking about if you have questions or you have strategies or other resources that you would like to share with everyone. This is really supposed to be a collaborative environment. And in fact, I think that Lynn, myself, Daniela, we have as much, if not more, to learn from you than you will from us today. And so please make sure like your strategies, your thinking, resources are shared in the chat. At the end of today's session, we will download the chat and produce a curated list of ideas, resources from the chat that we'll share with everyone. So your thoughts, your resources will not get lost. We'll make sure to share those in the Padlet, which I'll go over here soon. And again, participating in breakout rooms is a must. So the agenda for today, right? The goal today is that we're collaboratively engaging with this changing Arctic ecosystem curriculum. Everything, all the resources that we're going to play with today are in the Padlet, this whole group landing page that Lynn just added to the chat. I'm gonna just pause for a moment here and take us to this Padlet and do a quick orientation, because while I do think this is a really valuable resource and way to organize things, it's also can be a little bit overwhelming. So wanted to go through these 4 columns real quickly with you. So workshop logistics, really what you need to know here, here's my contact information for those of you that don't already have that. And please be sure to reach out to me if you have questions about this unit, about other units, about what other needs you might have. Please reach out to me. My favorite part of the job is working with educators. Believe it or not, it's not sitting by myself in my house. So thanks in advance for keeping me in the loop and be using me as a resource. In this second column, workshop resources, here's the link to the slide deck for today. And then each of the lessons, the lesson title, and different engagements and resources that we'll be talking about are listed. So for lesson 1, there's a link to the student worksheet, some of the videos and virtual reality tours we'll be playing with, a list of jam boards. I think that given the fact that there are 20 something of us, we probably don't need to go by last name Jamboard. In fact, I think it might be more fun if we all use one. So maybe we'll all just use last name A through H here, just so we can get a bunch of ideas in one space. Initial models, those of you that have worked with me in the past, I think you know what's coming. and then lessons 2 through 7 outlined here. Post-workshop resources, we've got an exit ticket we're going to ask you to complete here, largely so that we know what worked and what didn't work, and also to get your information should you be interested in receiving a PD certificate. And this will be a 4-hour PD certificate unless you decide to complete a final model and written explanation. Again, most of you that are here today have already been in some sort of workshop with me before. So you know kind of what these tasks are. If you complete these 2 activities, which I'll describe at the end of the workshop today, we'll give you a 6-hour PD certificate. This last column here is other curricula. Our Arctic feedbacks unit that's centered around the anchoring phenomena of Arctic amplification that some of you already engaged with. This is another Mosaic inspired unit. This unit here, the future of forests, is not inspired by the Mosaic Arctic Research Expedition, but follows the similar instructional framework, which I'll describe here shortly. And then a new resource we're in the weeds with right now. Lynn is really taking the lead on this, doing a great job. Data Puzzles is a resource that incorporates authentic data and research-backed instructional practices of ambitious science teaching and brings that into a 3-4 day kind of experience. So some really exciting work that we're proud of. And again, it's all included here in this Padlet. Without further ado, what I would like to do now is just give us an opportunity to meet one another briefly in a breakout room space. Given that we're going to be back and forth between this main room and the breakout rooms a number of times today, I think it's really important that you have an opportunity to at least introduce one another, share where you're from, what you teach, what you're looking forward to, what you hope to get out of this workshop. And when you come back, here's your task. In the chat, we're going to ask you to share what one goal that you have or what you hope to get out of this workshop. So you're not only introducing yourself, but also sharing a goal for this workshop. And we're going to ask that you post that goal in the chat when you return. I think about 5-7 minutes will be what we'll put this at, and I'll give you a 1-minute warning. So with that, the breakout rooms are open. Great, thanks for engaging in that. I'm just closing the rooms now, so we've got about 40 seconds until everybody returns. Those of you that are coming back a bit early, if you could right now add one workshop goal to the chat. Like, why are you here? What are you hoping to get out of this experience? And that might help us a bit in terms of shaping, the way the next few hours go. So welcome back. Those of you that are just joining us, asking you to share in the chat one goal of yours for today's workshop. Wow, cool, Deborah. Nice. That's exactly where I want to go next with the extension lessons and think this. We're going to be looking at the flow of carbon through the Arctic food web, but declining sea ice and the access to carbon fossil fuels has changed significantly over the past few decades. And so something that I definitely want to explore in a future lesson. New curriculum, new unit. Nice. Adding some different lessons or ideas to the Arctic feedbacks unit. I love that. That's one of the goals here. We're trying to make it so you can pick and choose and add different activities or ideas to lessons that you find engaging or that might interest your students. Data-driven resources, great. Biological content, great. Nice, thanks all. Really fun to read this. And again, really fun to have, to be able to start to develop some relationships with you all and have you come back and get to work with you. I think in this virtual space, that's one thing I miss is developing relationships with students or educators. And so having folks come back is really an honor. So thanks for that. So What we're going to do right now, I know many of you are going to be familiar with this, but I'm going to spend some time right now just describing the instructional framework that we utilize to write the Changing Arctic Ecosystem unit. And so for those of you who might not be familiar, this instructional framework is called model-based inquiry. It's the framework that I was trained to write when I went to grad school in Arizona. And it's a framework for designing science units around the construction, revision, and testing of models by groups of students as they seek to explain natural phenomena. And this term phenomena, when I'm using that term, I'm saying observable events. So something that we can observe. And what's critical in these model-based inquiry units is coherence. Students know what they're doing, why they're doing it, how it relates back to this observable event. So there is a complex and engaging phenomena that anchors the instruction here. And in lesson 1, we'll look at that phenomena and I'll introduce to you a unit driving question. And in lesson 1, we're going to elicit students' ideas. In the case today, I'm going to ask you to put your student hat on, put yourself in your student's shoes, and come up with some ideas, some initial explanations for the driving question that I'll present to you in just a moment. After that initial lesson, where we develop initial conceptual models from those ideas that you come up with, each activity thereafter provides students with a bit of evidence that they will use to construct a final model or evidence-based explanation for that unit driving question. And so embedded with all of this are NGSS practices of modeling, explanation, argumentation. We utilize lots of public records, summary tables, gotta have checklists, so that student ideas are made public. They're at the forefront of this. We can utilize student ideas and student language as resources early on, and then we can track changes as new understandings arise from these different activities. And again, the learning is collaborative. What's included in this curriculum? And I wanted to stop and pause here, given that many of you have already engaged with Arctic feedbacks or the future of forests, or maybe this is your first time. I wanted to show you what the website curriculum pages that we developed, that I developed, I guess I should say, what they look like, and just talk about the current state of this website. So this website, again, this curriculum is, I'm going to add the link to the chat. It's also in the, Lynn's already on it. It's a work in progress. For those of you that have already seen Arctic feedbacks, you know how it will be modified. There will be some text about some background information about the unit. I'll have a unit summary and instructional calendar. And then there will be lessons with teacher guides. Make sure you have access to all of the resources in a Google Drive folder and description of each lesson. With the Changing Arctic Ecosystem unit, why we're all here, I'm not quite there yet. So this is again a draft, but I've got some text that drafted. I just need to add here. I have to update that unit summary to include information specific to this unit. The teaching materials, lesson 1 through 7. Note that there will be a couple extension lesson for, I can't remember who, for history teachers and those looking for cross-curricular ideas. That's what's coming, lessons 8 and 9. So this will be continued to be modified into the fall. Taking a look at this first teacher guide, all the teacher guides will look the same. There's a little bit of information about the lesson, setting the stage, and then each lesson I break up into parts. So lesson 1 has 6 parts. In this lesson overview on the first page, I estimate how long I think each part will take, and there's a brief sentence about what students will do in that part. Page 2 is an instructional overview table that has the approximate instructional time. Usually for this first lesson, eliciting a student ideas about a driving question might take 120 or more minutes. Some unit and lesson driving questions. We're building toward a couple of NGSS performance expectations. The 3 dimensions that are included in this particular unit are referenced, some statements about what students will do, and then in the materials, a slide deck, a student worksheet, and all of the things that are referenced and utilized in this lesson. Pages 3 through 5, try to keep these teacher guides to 5 pages or less. I describe what you will be doing with students in each part. So part 1, you're watching a little bit of a video here. Sometimes I might even have sentence prompts, like this is what you should say here to segue into the next part. Part 2, we're looking at slide decks. There's a virtual reality tour. There's some optional supplemental material, and so on and so forth. So this is what you're getting, and what you'll get for each lesson. I guess I should open up these slide decks. They will have some notes, some in the presenter notes. So just want to encourage you to check that out. So for example, in this first part 1, what are we on, slide 4 here? There are some instructions and some like maybe helpful hints there. Links to different visuals and videos are referenced in the speaker notes. So make sure you're checking that out as well. And student worksheets and things of that nature. Everything is pretty comprehensive, like the other units you may or may not have engaged with. We really want this to be kind of plug and play, as little work on your end as possible. So the questions are all here. This is a guided notes piece, and some different tasks and things. So it's all here for you, and hopefully, should you be inspired to utilize this resource, it's more fun to facilitate and less work. Knowing that these are all in Google Docs, you can feel free to make a copy of these documents, bring them over into your Drive folders, and you can manipulate them to fit the needs of your students as you see fit. So just wanted to bring that up at the start here before we get too far into the unit. Without further ado, we are going to dive into this first lesson here, and I'm going to facilitate this for you as if you're students, and this is how you would do it with your students. And again, every slide that I'm presenting to you, these are slides that I've taken from the slide decks. And so what you see is what you get. And so here we are, lesson 1, a changing Arctic. And so in this lesson, students are going to develop a model to explain how declining sea ice might affect Arctic organisms. And so in this lesson, we're going to look at and watch a couple of videos and visualizations to show how the Arctic is changing, temperatures and sea ice. I'm going to use those videos to talk about the Mosaic Arctic Research Expedition. Lynn put together a really cool ArcGIS story map that talks about some of the different Arctic organisms and the encounters Mosaic scientists had with these organisms. And then from there, with some given that background information, we'll ask students to consider how declining sea ice might impact these Arctic organisms, and they'll be tasked with developing initial models from that. So I want to start with this. This is how you start with students. Some of you may have already seen this visualization, others not. But the Arctic is changing and global temperatures are increasing, but they're not increasing by the same amount everywhere. Not all warming is equal. And so in this video here shows how temperatures around the world have changed from 1880 to 2020 relative to 1951-1980 average temperature. So these are showing temperature anomalies. Blue is going to be showing temperatures cooler than this 1951 to 1980 average. Red, temperatures warmer than this 1951 to 1980 average. And we'll ask your students to consider where temperatures are increasing the fastest, and ask you to just keep your eye out for any patterns that you may see as you watch this 30-second clip. I know many of you have seen this. For those of you that have not, pay attention what's happening, especially in the northern hemisphere. There's no sound here, just a short clip. So you can see over the last 100+ years, a lot has changed, especially since the year 2000. You see a lot of warming in the northern hemisphere, particularly in the Arctic. And in fact, the Arctic is warming at a rate 2 to 3 times faster than the rest of the globe. And in that Arctic feedbacks unit, we explore, why the Arctic might be warming faster than other places on Earth. In this unit, that's not necessarily the emphasis, but it is interesting, right? Like a frozen ocean with very few people, that's the place that's warming most rapidly. And so maybe an opportunity to pause and think about that with students, but also thinking about the effect of that warming on that unique environment. Warming temperatures and declining Arctic sea ice, they're related. That warming temperature is what's kickstarting this decline in sea ice. And so there's a data visualization here you could watch with students. Here's a little graph that shows the change in September sea ice extent, the change in the minimum area of sea ice extent in the Arctic from 1979 to the present. And you can see the area of sea ice in September when they measured the minimum extent, the smallest area of sea ice each year. That minimum extent has declined by about 13% each decade since 1980. So we're seeing a dramatic change in that Arctic environment. Rapidly warming temperatures, declining sea ice. And that is really what inspired the 2019-2020 Mosaic Arctic Research Expedition. There really aren't a lot of on-the-ground observations from the central Arctic. And what happens in the Arctic doesn't stay in the Arctic, right? Our whole climate system is connected. And so scientists are up there studying this warming, studying how the decline in sea ice might impact warming and vice versa, and studying all other aspects of the Arctic climate system, including how that climate system might impact the ecosystem up there. And so a little bit of background about this Mosaic Research Expedition. It's one of the largest Arctic climate research expeditions ever conducted, with 500+ scientists from 19 countries participating. So in September of 2019, hard to believe, Lynn, we've been working here for 2 years. It's about when Lynn and I got hired. September of 2019, the German icebreaker Polarstern set sail with about 100 scientists on board for the Central Arctic in search of an ice floe with which to attach to. An ice floe just being a flat piece of ice. And once attached, the scientists on board deployed a series of instruments on that ice floe, again, to study all aspects of the changing Arctic climate system. Together, the ship, the research equipment on the ice, the scientists, they drifted across the Arctic along ocean currents for the next year, studying all aspects again of that Arctic climate system. What's happening in the ocean, what's happening in the ice, what's happening in the atmosphere, and how are things transferred between the two. And so with that, what I wanted to do is just provide you with an opportunity to watch a quick video about the Mosaic Arctic Research Expedition. It's about 3.5 minutes long, and I think it's a much more concise and visually, obviously aesthetic summary of this expedition. And I think it would work well with your students in terms of getting them psyched about the expedition and providing them with the background information that they need. So I'm going to play this. My hope is you can hear the sound. I think you can. We'll see you in 3 minutes.
The Arctic, the northernmost region on Earth. Cold. Remote. Even here, the extent of global warming can clearly be seen. The Arctic ice is rapidly thawing, with dramatic consequences for our climate. In order to better understand the climate processes in the Arctic, we need to take measurements year-round. To reach the central Arctic in winter, the Polarstern must freeze herself in the ice and take the natural ice drift all the way through the Arctic Ocean. This is the Mosaic Expedition. Under the direction of the Alfred Wegener Institute, scientists from all over the world are working together and have set up a research camp on the ice. This includes an ROV city, where researchers use remotely operated vehicles, ROVs, to collect observational data under the ice and transmit it back to the surface. There's also an ocean city, where the experts lower measuring equipment through holes in the ice and haul water samples to the surface. There is an ice research camp, where researchers study and observe the sea ice and snow cover. There is a Met City and Balloon Town, where the researchers collect data on the atmosphere and air composition. Up to 50 kilometers around the Central Observatory, several dozen ice monitoring stations have been installed. They drift with the camp, autonomously recording and transmitting measurement data along the way. Additionally, aircraft augment the study of the ice, atmosphere, and clouds by taking measurements from the air. Icebreakers from international partners are available to exchange scientists and crew as needed. The overall structure, the Polarstern, research camp, and surrounding measuring stations will all drift through the Arctic for an entire year, collecting valuable data. This data will be vital to understanding the Arctic climate and how it will impact the rest of the world.
Cool. So yeah, that video really does a nice job. It's got that dramatic music, the narration, really great animated graphics there to kind of bring students to the ice, so to speak, and get them a little bit more familiar with that expedition. Again, this changing Arctic climate system is what drove that 2019-2020 research expedition. And want to just mention, while the field work portion of that expedition is done, it's finished, people are back home now, there's a lot of new and exciting discoveries yet to come. So Lynn and myself and others, our job is to continue to develop Mosaic-inspired resources for the next couple of years. So while this is one of those resources, want to keep your eye out for that. Once you've kind of provided students with a little background information, shown them that video, we also want to provide the option to actually take students to the ice. We have had a number of 360-degree cameras up in the Arctic with these Mosaic scientists. And with that footage, wanted to give students an opportunity to visit the ice with these virtual reality tours. And so I'll have Lynn just added that link to the chat to this virtual reality tour, and want to give you all a few minutes to play around with this. And those of you that have already seen this, well, I'll add another link to the chat with some other virtual reality tours that maybe you haven't seen that might be of interest to you. So after showing that video, give students an opportunity to visit the Arctic with this virtual reality tour. The Arctic is really a foreign place. Not a lot of our students maybe have thought about the Arctic or know what it might look like or what it might feel like to be on an expedition. So in this tour, you have the opportunity to click and go visit some different sites, seeing scientists as human beings that have a playful side, playing soccer on the ice. Where else can we go? Checking out some different water sampling in Ocean City. They call these research camp cities. And you can see this hole in the ice, some different water sampling equipment. These eye icons are just little information icons, describe a little bit about what you see. You can go visit Miss Piggy, a weather balloon, and learn a little bit more about that. And so I want to give you 5 minutes right now, just on your own, to play with this virtual reality tour. Those of you that have already engaged with this resource in the past, I'm going to add this link to the chat right now. And this is a link to this page. Oh, what was that? That's not the page I wanted. That what I added. Oh, okay. This page here that has that Mosaic Ice Camp virtual reality tour that I just demonstrated for you, but it's also got a number of other virtual reality tours, including some videos where you can click and drag through the videos. So it's a pretty extensive library. We even have some planetarium shows, opportunities to get on the Polar Stern, that research vessel, and check out the different rooms. So we'll give you a few minutes now to not only play with the Mosaic Ice Camp tour, but also check out some of these other virtual reality resources that are available to you. Why don't we'll give you 5. I'll start a timer right now, and I'll set it for 5 minutes, and then ask that you come back in 5. I'm going to stop this timer so it doesn't yell at us, and dive back into the slide deck. Great. So I'm glad that you all had an opportunity to either play with this Mosaic Ice Camp tour or check out some of those other VR experiences that we have available in that library. You know, Michael requested that we keep track of those resources in some way, shape, or form, and hopefully, you know, we can get everything in that Padlet, and that can be a nice landing page for you. Yeah, Susan, if you could. That polar lab from NOVA is really impressive. And if you haven't checked that out, folks should check that out as well. Again, want to make sure that you know that everything's going to be in that Padlet. So we don't expect you to digest all of this in the 4 hours today, or be able to spend enough time with these resources in this 1 4-hour chunk. So again, keep checking out that Padlet. It's not going anywhere. We'll make sure that it stays as is for maybe forever. I'm going to continue to make new Padlets for each workshop. So that should be a resource for a long time. So after you've taken your students to the ice, kind of a fun way to get from the expedition into what we're going to be talking about here today, the Arctic ecosystem, is to mention that those Mosaic scientists, there are ecosystem scientists up there trying to understand how the changing Arctic climate system will affect the things that live there. And throughout their year-long fieldwork, these scientists encountered a number of Arctic organisms, including polar bears. These curious polar bears are like, what's going on in our backyard? We have these new instruments. We have this ship frozen in our backyard. And so we've got a mom and a cub here, kind of checking out the Polar Stern, that German icebreaker that was the home base from afar here. This curious polar bear is checking out some of the research equipment, and there were some instruments that were affected by these curious polar bears, but fortunately, no polar bears, no humans were injured or affected during this year-long expedition. I did add a link, an extension to this lesson that's an interview with a Mosaic polar bear guard. So when the scientists were out on the ice, they had polar bear guards with night vision goggles and flare guns. And of course, they had rifles as well, but the job of that polar bear guard is to keep watch, make sure that everyone keeps a safe distance, and to not have to use that rifle, which gratefully they did not have to do that. Some other encounters, these Mosaic scientists on Team Ecosystem they used nets to check out what was living in the water column. And so we've got some different zooplankton shown here, tiny critters, tiny animals in the water column, a krill here and copepod, a copepod that they collected and they were looking at under a microscope. And they can even get a sense of what these copepods were eating through these different images, which is pretty cool. These scientists were also studying what was living in the ocean under the ice using remotely operated vehicles. And again, there's an extension in the lesson that has a 3-minute video clip that talks about remotely operated vehicles and Mosaic. And so you can see at the top here, here's a polar cod. They can survive in cold waters and actually in that freezing ice because they have a protein in their blood that kind of acts like antifreeze. And this image at the bottom, you can barely make out. Here's a seal, an image of a seal captured by these remotely operated vehicles. So a lot of different fun animal encounters. And Lynn did a really nice job, not only describing these Arctic organisms, but also describing these organisms from the perspective of the scientists. These Mosaic scientists had blogs that they would update daily, weekly. And so Lynn captured some of these blog entries and described these Arctic organisms. And we've put that into an ArcGIS story map called Plants and Animals in the Arctic. So the reason that this resource is included is because I felt like probably a lot of students, they might not know very much about the Arctic organisms that live there. And so if we're going to ask them to predict how that changing climate, changing sea ice will impact these Arctic organisms, they might need to know a little bit about the organisms before they can make those predictions. So this resource, which Lynn just added to the chat, is designed to provide students with some background information about some different animals, plants and animals up there. And in the student worksheet, there is a task that students would complete while they engage with this resource. Largely, they're looking at the diet and habitat of the various organisms that we introduce here. And so what students would do is just scroll through. At this point, you've probably already introduced Mosaic, and here's that same overview video. So students can kind of skip past that if they need to. Here's a video that looks at how sea ice has changed over the last 40 years, showing that decline. And then an introduction to some of the Arctic organisms that live up there. And then we go through starting at the base of the Arctic food web, looking at Arctic algae, describing the 2 different types of algae that live in the Arctic. Those that grow in the open ocean, they're called pelagic algae, and other algae that grow in the sea ice algae, I call it in this unit, or sympagic algae. And so wanted to give you 5 minutes right now, another 5-minute break, to play with this ArcGIS story map and have you actually consider, read up on some of the adaptations, the habitat, the diet of these different organisms. Because I'm gonna ask you to draw on some of the things that you learned by engaging with this resource to help you answer the unit driving question, which I'll present to you in a moment. So your task, take the next 5 minutes, play with that ArcGIS story map. And also in the chat, I am going to add, I guess it's already in this Padlet, so I'll just click here. I'm going to add a link to the student worksheet. And on the second page of the student worksheet, this is the task that we ask students to complete while they engage with this ArcGIS story map. So you've got 5 minutes, you're playing with the ArcGIS story map. If you get a chance, maybe check out the student worksheet so you can see what we're asking of students while they engage with this resource. And we'll just give you a few minutes to think about what's all going on here. I'm going to dive back into the slides here and use kind of these experiences to help lead us to that unit driving question, right? At this point, we know the Arctic is warming. We know sea ice is declining. We've learned a little bit about the Arctic organisms that call this unique environment home. And so the question then becomes like, how might the decline in sea ice affect Arctic organisms, large and small? And so this is our unit driving question here. What is going to happen to all of the plants and animals that have adapted to this environment? Are some going to struggle? Are some going to thrive? What do we think? And so presenting students with this question, given now that they have a little bit of background information, the task then is this, and I'm going to ask that you participate here in just a moment. Given the question, how might the decline in sea ice affect Arctic organisms, large and small? I'm going to ask you to come up with some initial ideas, some initial explanations for this unit driving question. This is what you would do with your students. If you were in person in the student worksheet, there's actually a space for students to write down their initial ideas, which they would then share with the class. And you might add on a piece of butcher paper. That's what I used to do in my classroom. Or maybe you add it on to a Google Jamboard or a Google Doc. Whatever it is, we want to make sure student ideas are about the unit driving question are made public. And so we're going to now, I'm gonna ask that you put your student hat on, and I'm going to just ask that we use one Jamboard. So I'm gonna add, Lynn, did you do A through H in the chat?
Yep.
Awesome.
That's
So I'm gonna
easy.
ask that we just use the one Jamboard that Lynn added to the chat. And for those of you that may not have used Jamboards, I've got this question here, a little picture that shows you some of the different organisms that live in the Arctic. And using these sticky notes here might benefit polar cod in some way. I'm not sure, with warmer water. Whatever a student idea might be, you know, thinking about the different organisms they were just introduced to, what they know based on their diet and habitat and different adaptations. How might the decline in sea ice affect Arctic organism, large and small? Asking you now to share one or two ideas on this Jamboard so we can create an initial list here. We'll give you a few minutes to do that. Thanks all. Already a great number of ideas here. I've seen a lot of comments about food availability, really good questions about, you know, what's in a polar bear's diet, and maybe something that we need to investigate further in a future lesson. Maybe that didn't come out in that story map, and we really need to evaluate, you know, what are these different things eating? How are they connected by the flow of energy? Thinking about the food web, maybe the size of the species matters. So I'm seeing a lot of ideas about food, energy that might affect things like reproductive success. A number of you have brought up ideas about algae, which are the aquatic plants of the Arctic, and how we have two different types of algae. I'm seeing some vocabulary terms, sympagic coming out. So maybe students start to use some of those terms that were introduced in that story map. So sea ice algae that grow on the underside of sea ice, how might they be impacted? I saw somebody mention sunlight and maybe an increase in the amount of sunlight to the photic zone in the ocean with less sea ice. So some comments about changes in hunting grounds. So again, with that loss of declining sea ice, how might that affect the hunting grounds for polar bears, or, you know, these other organisms that depend on that ice as their habitat? A really interesting question here, thinking about copepods and their life cycle. From that story map, you learn that copepods have timed their life cycle with these sea ice, these sympagic algae blooms. And so, you know, what might happen if those blooms happen earlier or later? A lot of really awesome questions, comments here. And I saw in the chat a long time ago, I'm not sure if you're still here, Miss Champagne, but somebody brought up a driving question board, which is something that we don't include in the teacher guide, but would certainly encourage you to do if you're comfortable with that. And more or less what that is, after you introduce this unit driving question, what would, in an ideal world, like students are really curious about this and they have a lot of questions themselves. And so you can, what Miss Champagne is referencing here is, you can keep track of those student questions, almost like a word wall, but put those questions in a space, give them sticky notes or have them write them on butcher paper, give them a piece of paper, and you can put those questions in one space, and we can try to answer those questions throughout the unit. And if they're not necessarily answered in the unit, students are generally inspired, a couple of them maybe, to go find the answers on their own and share it with the class. So it's a really awesome way to get students involved and have get some ownership and some buy-in with the unit. So we've got a huge list of ideas, explanations here. I love it. And again, one thing, when you're facilitating this, inevitably, I think what will come out, things about ideas about food availability, diet, food web, really wanting to emphasize those things, because the next series of lessons, we're going to kind of explore the Arctic food web. We're going to explore what these organisms are eating and how changes to one part of the food web might disrupt or affect other parts of the food web. So just highlighting that now as the facilitator, like you would want to do with your students, because that's kind of the direction that we would be going. At this point, however, what we want to do is make sure we're respecting all of these ideas and explanations as valid, things that we're going to continue to explore as a whole class. And just acknowledge that we don't know the answer yet. And in fact, this is an emerging field of science that scientists don't know the answer to this question yet, but we're trying to gather evidence to be able to predict how this change in sea ice might affect different organisms. So after you've created that initial idea list with students, students are going to be using, and you will all be doing this here in just a moment, using those initial ideas to create an initial conceptual model to represent that unit driving question. How might the decline in sea ice affect Arctic organisms, large and small? And so these are slides directly from lesson 1. Those of you that have participated in workshops with me before have seen these. But if your students have not yet developed an initial conceptual model or a scientific model in your classroom, use these slides to introduce scientific models as representations of ideas or processes to explain observable events. And so we use models to visualize explanations, to test or revise ideas, to make predictions, and they can take many forms, including annotated drawings, computer simulations, among other things. In this unit, and in all of my units thus far, we utilize annotated drawings for students to create scientific models and make their thinking public and visual. And so in this unit, and again, in all units that I've developed, we use these annotated sketches, descriptive models that include drawings, arrows, text to communicate ideas. And so before a student can construct a descriptive model, they need to consider the relevant parts. So in this case, with regards to the unit driving question, how might the decline in sea ice affect Arctic organisms? Like, what parts do I need to include in this initial model? How do I connect the different parts? Do I use arrows or zoom in windows or some sort of timeline to show how they're connected? And do we have any data or evidence to support our thinking? And at this point, we don't really have data or evidence in this initial model phase. That evidence comes through the different lessons that we participate in thereafter. Also, with your students, wanting to make sure that they are at least introduced to different signs and symbols they could utilize to connect relevant parts. So arrows to show the movement of things, perhaps a key to help us understand symbols or ideas, zoom in windows, text boxes, timelines, partitions. So lots of different signs and symbols to connect these different parts. And Again, those of you that have worked with me previously, this is the same example I've been giving for a year now. You know, I wanted to offer up a conceptual model, annotated sketch, where something might be something students might be more familiar with. And in my case, when I was in an 8th grade classroom, it was definitely Marvel movies. And so presenting them with the question, why does the Black Panther get stronger after being punched? And, you know, utilizing a key, different illustrations, kind of a timeline here to represent this, you know, a meteor coming and crashing into Wakanda and depositing this element vibranium. And then, you know, the folks there in Wakanda extracting this vibranium and figuring out it has all these unique properties. One of which is that it can absorb kinetic energy and then like utilize that energy in different ways. And so it's incorporated into the Black Panther suit. So really, you know, a way to get students like curious and maybe excited about creating their own conceptual model. So after you go through all of that, right, like what's a scientific model? What are the signs and symbols that you could utilize? What's an example look like? The task then is that students work in pairs. I never liked groups of 3. Someone's always in a group of 3 not contributing to this initial model. So you in a classroom with one other person, their job is to look at all those initial ideas that are on that public record, what you just created in the Jamboard. Encourage them to use more than one, or, you know, change if they saw an idea they like more on there, like they can change their thinking. But they're going to consider which parts based on that Jamboard, that public record, they want to include in an annotated sketch that represents this unit driving question. Consider how they'll connect those different parts with signs and symbols to construct that initial model. And so that's what we're going to ask you to do right now. I'm going to give you 15 minutes to construct your initial model for this unit driving question. And I'll pause here real quick. We're going to do this online. I've developed a shared Google Slides document that I'm going to ask that you annotate. However, in your classroom, we offer a couple of things. One, here's the initial model student worksheet. And so this is that blank back environment that we would ask students to, you know, answer this question on. So how might the decline in sea ice affect Arctic organisms large and small? We've got some sea ice, the sun, the ocean. And we also include some Arctic organism cutouts because we don't want necessarily students to be overwhelmed by, you know, drawing these organisms. Some students might want to, but we offer these cutouts. And in fact, in this unit, we're going to focus on these 7 organisms. So we don't want students to get too overwhelmed, right, with how many different organisms there are up there. We're going to focus on these 7. And so in your classroom, you would provide student groups, student pairs with one of these background worksheets, and then one sheet that has these cutouts, and you would ask students to cut them out. They would attach these images to this worksheet and then add some text boxes, some zoom in windows, whatever they would need thereafter to answer this unit driving question. So again, that's all in this teacher guide. For online, Shannon, and perhaps this will answer your question, your task is going to be something a little bit different. And so I'm not sure. With regards to that Black Panther model, Mr. Fairley, you can grab that. It's in this presentation, so you can make a copy of this presentation and take that Black Panther image. And so I'm going to add, Lynn's already added the assignment to the chat. I think I've gone a little long-winded, so I'll explain your task here again. But each of you is going to be, have to make a copy of what Lynn has just shared in the chat, and it's going to take you to this page here. And so this is a slide deck. The instructions are that you create an initial model to explain the unit driving question. How might the decline in sea ice affect organisms large and small? Your model must include these 7 organisms. And I also include these kind of signs and symbols on that first slide. The second slide, it has that background image, which cannot move, but you have access to these organisms where you can move them around, you can resize them. We'd encourage you to add text using the text boxes. If you want to add other images, feel free to add other images, shapes, lines and arrows, drawing tool. So your job is to manipulate, to modify slide 2 here to explain how the decline in sea ice might affect these Arctic organisms. We're going to give you 15 minutes now to do this. So I'll set a timer for 15 minutes. I would encourage you to keep this Jamboard available. Check that Jamboard out. There might be some ideas on this Jamboard that you want to think more about that you might want to include in your model. And that's your task. After 15 minutes, just so you know what's coming next, I'm going to send you back to your breakout rooms and ask that you share your initial models with your peers, with your colleagues, just so you can all kind of get a sense of what everyone is thinking. And that's what you would do with your students. So I'll be here to answer any questions, but your task again is to create an initial model utilizing this Google Slides presentation and manipulate that to answer this question. It may take longer. This would likely take longer than 15 minutes in your classroom, but you know, hopefully this shows a couple of different ways that you could help students take ideas from that initial ideas list and make them visual in this conceptual model. I'm going to stop now so it doesn't yell at me. And Susan, I'll answer that question in terms of how you share that work with me in just a moment. There are a couple of ways. One, you could share the document with me. 2, I've also created a Drive folder, which I'll talk about here in just a moment, which could be cool if you download your models and add that downloaded model to the Drive folder. Then we could look at everyone's, but I'll talk about that in just a moment. Going back to this slide deck real quick. Again, after that 15 minutes, maybe that was too much time. If it was, great. Hopefully you had an opportunity to stretch your legs. But after students construct their initial models, it's really important to give students an opportunity to share their models with one another. Learning's collaborative, and sharing ideas allows us to hear what everyone is thinking and refine our own ideas. So if you're in person, my favorite way to facilitate this model sharing exercise was through a gallery walk. And for me, I used to leave models on tables or taped up against walls and have students with their partner, with their pair, circulate. You could also do it where students had sticky notes and they could maybe take some notes about things they liked from other models that they would like to add to their model. I've seen other classrooms with sticky notes add different like tips or strategies, suggestions to others' models. If you're doing that, you might want to have students put their names on the backs of sticky notes. So there's some accountability there, but lots of different ways to do this. What we'll do here is just have you go back to your breakout rooms in just a moment. You all have the ability to share your screen. So in your breakout rooms, just kind of circulate who shares their screen. And it would be great if you would all share your initial model, share what you came up with, share what this experience was like. And then we'll reconvene after that in this main room and we'll break for a 30-minute lunch break. So the activity here is that you head to your breakout rooms in just a moment, utilize the share screen function. So each of you has an opportunity to share your initial models with one another. And then we'll give you 5-10 minutes to do this. We'll reconvene back in this main room and then break for lunch after that. Hopefully you had an opportunity to chat with one another at least a little bit. And hopefully most of you had an opportunity to share your initial models. with folks. Again, this was done in a virtual environment. If your students are virtual, hybrid, whatever it looks like this fall, maybe you try it out this way if you facilitate this unit or other modeling activities. But again, so you know, the idea that I initially had was there is a document that you would print out. There are organism cutouts that students would attach and annotate to develop these initial models, give students an opportunity to share their models, and that wraps up day one, or lesson one, I should say, a changing Arctic, where we introduce the unit driving question and give students an opportunity to think through it a little bit and share their ideas, again, publicly in a couple of different ways. At the end of this lesson, you know, we acknowledge like this is our starting point. This is our diagnostic assessment, and everything we do from this point on, each subsequent lesson, each lesson to come is designed to provide students with a bit of evidence to help them model and explain how might the decline in sea ice affect Arctic organisms, large and small. Again, they might not know this right now, but you should know their final model, that final assignment is the very same, is to manipulate the same resources that you just did. So they'll get the same cutouts, the same background photo. And again, it's going to look different because they'll have learned some new material throughout the unit. So again, you can, like I think Ms. Champagne said, you know, it's a really fun way to have students keep track of new understandings by revisiting these models and revising them. I want to introduce this summary table, which is something that you would do with students after each lesson to come here. And it's a way to keep track of new understanding and how they relate to the unit driving questions. So they're going to, after each lesson, you'll write the lesson name. You'll keep track of ideas and new learning outcomes from each lesson, and then thinking about how they relate back to that unit driving question. And it's a really important public record to keep up to date during the unit. And then it's a resource that students are encouraged to use when they develop their final models and final written explanations. So again, making sure students have all of the resources, the tools they need to answer the question. And I think, you know, keeping track of this in a public record really helps with that cohesiveness and helps students understand what they're doing and why they're doing it. So we'll update this in the afternoon today as we engage with lessons 2 through 5. That said, we need a 30-minute lunch break. However, there's one task that we're going to ask that you complete during your lunch break. And Lynn is going to add it to the chat right now. We're going to ask that you download that Google Slides initial model document, download it to your desktop, and then upload it into this shared drive folder with your last name, the file called last name and then initial model. And this is one of my favorite exercises, at least for me. I love to go look at what you all came up with, and it would encourage you all to check out your peers' work in this shared Google Drive folder. Again, when you share your models with your small group, you're looking at 3 or 4 others' work. This gives us an opportunity to look at, you know, a larger sample size, and it's really fun to see what ideas people came up with, and again, thinking about different ideas that we might want to incorporate in our own models in the future. So 30-minute lunch break, grab your lunch, get outside, but please, if you could upload your initial model to that shared drive folder in the chat, we'd appreciate it. Lynn and I, Daniela and others, we look forward to checking out your initial models there. So welcome back, folks. We're gonna keep rolling here. Like I was just rambling on about this morning, really fun morning. Hopefully you all are enjoying this. It's really fun for me to have an opportunity to facilitate this unit for the very first time and figure out what works, what doesn't work. So I appreciate you all kind of being guinea pigs for me as I try to work out all the challenges and sticky points here. But really a busy morning, a lot of mosaic related resources shared. Again, those resources are going to be in this Padlet. We just finished lesson 1, so student worksheets, videos, story maps, Jamboards, as well as that Drive folder where your initial models are currently housed. So we've got a number of different models in here to invite you to check these out. I think it's important to see, the variety of models that could be coming your way, the variety of ideas, and good preparation for your students should you facilitate this unit in your classroom, just to have an idea about what's coming and how you can kind of navigate these ideas and bring them all together. So what we're going to do right now, on the wrong slide here, we're going to dive into lesson 2, which is called kind of a boring name, but Arctic feeding relationships. And so this is kind of a natural progression. When I was looking at your Jamboards and your ideas earlier, obviously want to make sure each idea is respected and validated. However, I was kind of pulling out, I was trying to say like, oh, this is an interesting feeding relationship, energy. We need to know what polar bears eat. Like there were a lot of things on that Jamboard that kind of helped us get to lesson 2. And kind of inspired this. We need to, if we want to understand how organisms are going to be affected by the decline in sea ice, we need to know who eats whom. We need to know how they're all connected. And so that's kind of how we navigate from that lesson 1 to lesson 2, Arctic feeding relationships. And so in this lesson, students are going to complete some notes related to these Arctic feeding relationships. And then I've got a series of different organism cards. The students are going to learn more about different Arctic organisms, and they're going to build their own food chain, and then they're going to build their own food webs. And so just kind of to navigate us, go from lesson 1 to lesson 2. We know Arctic temperatures are increasing. We know sea ice is declining. We know the Arctic is home to a variety of organisms, plants, and animals. And what we don't know those different feeding relationships yet. We don't know how the decline in sea ice might affect these different feeding relationships. So that's the purpose of this particular lesson. And with this lesson, I thought it might be best really for us to kind of look at this lesson from teacher perspective, and we'll look at the student worksheet and these Arctic organism cards and send you a way to build your own Arctic food web in here in just a moment. This lesson starts out with a couple of different just PowerPoint slides going over different organisms, introducing some different vocabulary terms. And so I thought that rather than, give a lecture here today about what a producer is, we could kind of skip that piece and take a look at the student worksheet together. And so I have some warm-up prompts in some of these student worksheets. This one is just, what's your favorite Arctic organism, and giving them an opportunity to have a say in what's going on and share their thoughts and feelings, and then have some different notes that are all linked to different slides in the slide deck. So notes about a food chain, about what the arrows mean or represent, and then we go through some different vocab terms from producers to the different types of consumers, offer brief definitions, give an Arctic example, and then invite you to consider a local example as well. After that, there are a few questions related to the Arctic food cards or organism cards that students are going to get. And I'll show you those organism cards now. Basically, we've got a series of pages here that have images of particular Arctic organisms, give some information about habitat, diet, predators, social groups. Some of them have some fun facts as well. And so I don't know how many, 6 pages of these different organisms. So you might be able to kind of guess where we're going with this, but just wanted to show you what the resources included in this particular lesson are. And so what students are going to do, thanks Lynn, Lynn's added those to the chat. They're going to cut out these organism cards. They're going to sort them into piles, producers, consumers, answer a couple questions about what the arrows mean and how the direction of the arrows and why they're directed the way that they're directed. And then this question 7 here, students are tasked with selecting 4 cards to create a food chain. They need to start with a producer and include a primary consumer, secondary consumer, and tertiary consumer, and label those. So again, we're kind of taking those notes, we're using these organism cards, and we're building a food chain, incorporating those vocabulary words to try and reinforce those concepts. In part 3 here, creating their own food web, we talk about what a food web is, and then we task students with building upon that initial food chain they made. So they'll start with that same food chain, and then their task is going to be to add, what is this? Add another producer. So they'll have both types of algae, ocean and sea ice algae, represented in their food web, and then 4 other consumer cards. So when it's all said and done, there'll be 8 or 9 different organisms that they'll be tasked with creating an Arctic food web. And again, this is just an opportunity for students to become more familiar with the organisms of the Arctic, to explore and build their own food web. Again, these feeding relationships are going to be really important. Students are going to need to understand these feeding relationships if they're going to answer that unit driving question. So again, here largely just wanted to show you what the student worksheet looks like, and then what these Arctic organism cards look like. And then we're going to send you away here in just a moment to build your own food web and get a little bit more familiar and comfortable with the material that's included in these Arctic organism cards. So here is your task, and we're going to ask you to get back into your breakout rooms and do this together. In your breakout rooms, you're going to use the information provided on these Arctic organism cards to build your own food web. So the way that I guess I'll go to the next, no. So the task here is this. I'm going to add this link to the chat. I'll add this one, Lynn, right now. This is the link to the assignment. And what I would encourage you to do is maybe have one person on your team open this assignment. I'll do it right now. And then build the food web together from that person's screen. So like what I'm doing right now, here's what you're going to get. Here are all the different organisms that are represented and have their own Arctic organism card. And so if I'm in a group of 4, maybe, Daniela shares her screen and she has grabbed an arrow. And based off the information on those Arctic organism cards, she's going to start to build the food web together with the group. And so the other group members, they're checking out the Arctic organism cards. They're looking at the diet, the predators, and we're trying to piece together this food web together. So with that, we're going to send you back to those breakout rooms. I would encourage you, if you don't, how can I best get this information to you? So we need the build your own Arctic food web, the link to that. And maybe Lynn, we can have, sorry, Linda, I'm a little bit disorganized right now, but these 2 links here, the build your own Arctic food web and the Arctic organism cards, if you could add those 2 links to the chat, that would be great. One person is going to click on this build your own Arctic food web link, and that's going to take you to this slide deck. Everybody should have the Arctic organism cards open, and together you are going to build your own Arctic food web. We'll give you 5 to 10 minutes. I might bop into some breakout rooms to just see how this is going. But again, the purpose of this is just to practice this. This is what we would ask your students to do and get you comfortable with the information that's on these Arctic organism cards. So Lynn's got those 2 resources in the chat. I'm going to open breakout rooms. We'll give you 5-10 minutes to build your own Arctic food web together. Good luck. All right, folks. If I had to guess, that was not enough time. but that's okay. I think that the main purpose of that activity was to just get your feet wet and to know that that's what your students are going to be tasked with. Now, they wouldn't have to incorporate or utilize all of those Arctic organisms. The assignment asks that they choose a few, choose a producer, a primary consumer, right? Kind of from the notes that they took in part one of this lesson. But you could see there are different opportunities to differentiate here by adding more or less organisms to the food web, and kind of practicing again with these, identifying these feeding relationships and showing the flow of energy. And so here is an incomplete example that I threw together this morning, and I know from the cards you could add some more arrows, but a couple things that you might want to point out with your students, right, is that these algae are the base of the food chain, right? This is where energy is coming from, and really pointing out like the direction of the arrow matters. Basically, it shows the direction of flow of energy. Energy is flowing from these algae to the copepods, right? And so basically it's huitum. The copepods are eating the algae, so they are getting the energy from the algae. So that shows that direction of energy that from copepods. Copepods have a number of predators, polar cod, bivalves, bowhead whales among them. And you can see it just goes from there. So kind of a mess, but really important to show the complexity of the Arctic food web and really illustrating that these algae are that base of the food web. A couple of other things, one other piece of this lesson, after students build their own food web, they are asked to predict how declining sea ice, how this disturbance would affect organisms in the food web. And so they're asked to predict how sea ice loss would affect producers, how that might impact primary consumers, or however they might go about this. Now, for you all in this workshop, maybe this is already obvious, but for students, I'm not sure what their initial models might be. I'm not sure if students would start by constructing a food web in their initial model. And so if they haven't constructed a food web in their initial model, they likely haven't considered how sea ice might affect all the different parts of the food web. And so I'm not sure if it feels redundant right now to ask them this question, but I was, from putting myself in the student perspective, I imagine initial models being here, there, and everywhere, and this being a really opportunity to bring the food web in and then to really reinforce like this sea ice is going to impact different parts of the food web differently. Can you make some predictions? And this is what scientists are actively trying to do right now, specifically as it relates to these producers. And so I was having a conversation with Susan while you are returning from breakout rooms about, the power of satellite imagery and satellite data sets, and where we're going in the next lesson is, we have some satellite data sets and visuals which scientists are trying to measure how declining sea ice is impacting producers or the amount of food at the base of the food web. So that's kind of where we're going. So that was too much information. You wouldn't give your students that here. They build their own food web. They consider how declining sea ice might affect different parts of the food web. Hopefully you get to the understanding that all parts of the food web are connected by the flow of energy, and that if one part is affected, all other parts feel it. This is the first time in this unit that students will have been tasked with updating a summary table. So at the end of each lesson, lessons 2, 3, and 4, I guess, there are 2 questions that look like this. What did we learn in this lesson? And how did what we learned relate to the unit driving question? And so students would answer these questions by themselves or in pairs. And then when you, the teacher, the facilitator, wants to make the whole class summary table, right? Students have already thought about this, and you can have students share ideas and come to some consensus about what gets put up on this whole class summary table. So I'm going to show you an example, some of the things, what I hope students learn and what I hope, how they could relate it back to the unit driving question. In this case, this is lesson 2, Arctic feeding relationships. All organisms in a food web are connected by the flow of energy, hui tum. Food webs consist of many different food chains, and changes in one part of an Arctic food web can impact, fix that, other parts of the Arctic food web. And so those are really, that's really the take home point here, and that students understand that scientists are trying to understand how sea ice, declining sea ice might impact other different parts of the food web, specifically the base, in order to predict changes from there. With that, we're going to take a 5-minute break, and we'll go into lesson 3, all about that base. That's what lesson 3 is called, looking at how declining sea ice has affected the base of the Arctic food web, those ocean and sea ice algae. So I'm going to put a timer up for 5 minutes, and when we return, we'll get into lesson 3. Let's dive into this lesson and first acknowledge the fact that, you know, this is my attempt at humor. When I was in the classroom, trying to make jokes and puns, dad jokes, I guess I should say, or as they're sometimes referred to. Lynn and I always kind of have a competition about who can come up with different titles that are silly but also worthy of eye rolls. I always found that students like that, and I think Jennifer was commenting to me about how All About That Bass is it's a play off of a song, and if you felt compelled to, I would encourage you to sing that song for your students. I'm gonna skip that part today, but maybe offer that as an extension in the teacher guide. Encourage you to sing that to your students, get some buy-in. But lesson 3, All About That Bass, we're really looking at the impact of declining sea ice on Arctic algae. And so this lesson is dynamic, to say the least. There are a lot of different parts, and so we'll go through those different parts. See what I'm dealing with here? My gosh, thanks, Lynn. So there are a number of different parts here, and we'll be walking through the different parts together. There isn't a virtual engagement for us all here. It's mostly going to be me talking and hopefully you thinking about how this could look, what this could look like in your classroom. And so last lesson, we constructed an Arctic food web. We looked at different feeding relationships and made some predictions about how sea ice loss would affect the food web. And this is what scientists are actively trying to do. And they're doing this by studying algae, which are the base of the Arctic food web. And so today's lesson, this lesson, we're going to look at, you know, how algae produce food or energy, and then how the decline in sea ice might affect the ability of algae to produce food or energy. And so just, you know, I think for students at this point, largely review, algae are making their own food through photosynthesis. And I understand that this equation, this is not correct, but I'm trying to just keep it real conceptual here. Carbon dioxide, water, and sunlight are those starting ingredients, not necessarily in those amounts. And the product, I'm just calling it food and oxygen. Again, to meet the needs of your students, if you wanted to use glucose and include the correct formula, it would encourage you to do that. I'm trying to keep it simple. And maybe you'll see why as we continue through this lesson and the next one. So again, I got this visual here. We've got some carbon dioxide coming into the water, some sunlight, and that product is going to be food and oxygen. And so there's an investigation here where we're asking if students can observe evidence of algae doing photosynthesis. And it's this particular lesson that I'm referring to. If you're interested in implementing this lesson or this unit, there are a couple materials for this lesson that our group would like to purchase for you if you're interested in doing this. So many of you may have already completed a lesson like this in your classroom before, but it's this bromothymol blue is an indicator solution with an aquatic plant, either an algae or an alodia plant. And I'll show you the investigation here in a moment, but this is all really spelled out in a teacher guide and the student worksheet about the different steps. So they're not necessarily clearly displayed on the slides here. The way it works is the teacher could do this, or you could have individual groups do this. Fun, yeah, Donna, really fun. Yeah, you could create your own cultures of algae as well. But in this particular lab, which many of you may have seen already, right, you have water, in this case, in a little glass cylinder, and you add this indicator solution, bromothymol blue, to that water. The blue color represents kind of low carbon dioxide. And when you blow into this bromothymol blue solution, adding carbon dioxide to the solution becomes more acidic, and you notice a color change from blue to yellow. And so that color change represents the addition of carbon dioxide to the solution. So if you're thinking about like, all right, well, how does this relate to the Arctic? Just trying to show that atmospheric carbon dioxide can be dissolved in solution. And that's kind of what they're seeing here. And so once we have this carbon dioxide in solution, we know that took place because we saw a color change. Then that's our starting point. And then the experimental design piece goes from there. Rather than describe the experimental design piece, I'm just going to show you a video and maybe pause it a few times so that you can visualize what this investigation would look like for your students in their classroom. Again, there are a couple goals with this investigation. One, we're looking for evidence that algae or aquatic plants are doing photosynthesis. And we're also looking at the importance of light, sunlight in photosynthesis.
They're called producers because they produce the energy storage molecules for ecosystems. They make these molecules through a process called photosynthesis. During photosynthesis, plants take in carbon dioxide and water molecules. The plants change those molecules into energy storage molecules. We're going to do an experiment to test the effects.
So I'm going to pause this right now and just say, at this point in the video, the narrator has already added bromothymol blue, that blue solution, to water. They've already added their breath to that solution. So this is the color of the solution after the bromothymol blue after the addition of carbon dioxide. So you can see this yellow color. So that's the starting point now where we're at in this video.
Of light on photosynthesis. To do this, we start with 4 vials filled with water. We'll put a water plant called Alodia in 2 of them. We know plants take in carbon dioxide during photosynthesis, so to find out whether a plant performed photosynthesis, we can look at how much carbon dioxide is in the water around it. The water in these vials contains an indicator chemical that shows the level of carbon dioxide in the water using color. Yellow means that there's a high level of carbon dioxide, green means that there's a low level, and blue means that there is no carbon dioxide. These vials are yellow because they have a high level of carbon dioxide. Now we're going to leave some vials in the light and some in the dark to test how light affects photosynthesis. We place vials C and vial D under a light source. Next, we wrap vials A and B in foil so that no light can get in. We'll leave the vials for 12 hours to see what happens. Now that 12 hours have gone by, we're going to take a look at what happened. Did the plants perform photosynthesis? To find out, we need to look at the level of carbon dioxide in the water. We can see that the levels of carbon dioxide stayed the same in vials A, B, and D. However, vial C changed color from yellow to blue. The blue color indicates that no carbon dioxide is left in the vial. That's because the plant in vial C used all the carbon dioxide molecules for photosynthesis. The plant in vial C was under a light source. Even though there is a plant in vial A, the colors stayed yellow, indicating that the level of carbon dioxide remained high. That's because the plant did not perform photosynthesis. The plant in vial A was covered with foil, so no light could get inside. Without sunlight, the plant could not perform photosynthesis. Now we have clear evidence that plants need light for photosynthesis. The plant in the dark did not photosynthesize. Light is needed for photosynthesis to happen.
Yeah, Katie, good point. So there are some shortcomings of this investigation. And I think the purpose of, I have a clear intention for this particular investigation, but there is a lot more that could be explored with your students should you conduct this investigation in your classroom. The things that I'm most interested in with students, this first piece here, solution changed color due to the addition and removal of carbon dioxide. So that bromothymol blue is acting as an indicator solution. It's turning yellow when there is more CO2 and the greenish blue when there is less CO2. So again, when you're adding CO2 with your breath, you get to that yellow color. When the plant is using carbon dioxide and removing it from solution, you see a color change back to blue. And the reason that that's important in this particular unit is because this is evidence that plants are removing carbon dioxide from water, dissolved carbon dioxide. And that's important as we get into the next lesson, in which students trace the flow of carbon through the food web. So this is an important piece here where we're saying, all right, well, this is evidence showing that carbon is being taken in, from dissolved carbon dioxide is being taken in. The evidence is the color change, and what are plants doing with that carbon dioxide? They're making food. Another important piece here is that light is needed for photosynthesis to take place, and that will become important as we investigate the how and why. How has primary productivity, or more or less the amount of food in the Arctic, changed over time? And the why has the amount of food changed over time? It has to do with light. So a couple important pieces in this investigation. One, carbon dioxide is taken in by the plant. We can observe that in this investigation. Two, light is important. So those are the two big takeaways from this investigation. We'll build upon that. I want to pause real quick and just, maybe I'll open up the student worksheet here and just give us an opportunity to check that out here. So this student worksheet, I'm just diving right into this investigation with some background information, that simplified photosynthesis equation. Again, feel free to change this for your students. A key question, different materials, a pretty clear procedure here, and then some different data tables and analysis questions. So again, the big piece here is tracing the flow of carbon. Okay, so carbon from your breath is entering the water. The plant is pulling that carbon out of the water and using it to make food. And so wanting students to track that through this investigation. That's a really important piece here. Moving forward, kind of using this investigation as an anchor in some of the findings, we're going to apply that to a few different things. How does the decline in sea ice affect the ability of algae to produce food or energy? And so this is something that scientists are actively monitoring. basically the amount of food, the amount of algae in the Arctic. And they're measuring this using satellites. And so scientists can't possibly count the number of Arctic algae. They're microscopic and there are so many. Instead, they're using satellites to measure the rate at which algae make food. And primary productivity is basically the rate at which dissolved carbon is converted into food through photosynthesis. So higher primary productivity values are more food, more algae. And so there was a study, I think this was published in 2020, but it looks at primary productivity, the rate at which food is made for the Arctic from 2003 to 2019 across 9 different Arctic sites. And again, so what I'll show you here in just a moment is the average of all of these sites. So we're looking at the average primary productivity, the average rate at which algae make food from 9 different locations in the Arctic. And so in this particular graph, again, this is 2013 to 2019, looking at Arctic primary productivity from these 9 sites. On the x-axis is the year. The y-axis is primary productivity. So that, again, that's the amount of carbon these algae are pulling in and converting into food. And so more or less, I added a different unit here, basically the amount of food. Is there more, the rate of food, is there more food or less food? And so from 2013 to 2019, we can see an overall increase in primary productivity, the amount of food at the base of the food web available. So important here, a couple things. Again, that first investigation wanting to show carbon being pulled in by the aquatic plant, wanting to show the significance of sunlight. We have some evidence now that the amount of food available at the base of the Arctic food web is increased. What we don't know, and I'll tell you here in just a moment, this is for pelagic or ocean algae. So the amount of ocean algae, the food source from ocean algae, has increased. That's what this is showing. We don't know how the sea ice algae are faring as well. We don't have as much information on that. And so why has primary productivity, or the amount of food in the Arctic, increased over time? And for this, we look at some different satellite observations. And the satellite visual that we're going to look at here measures chlorophyll A. So individual algae, they're microscopic, but when they bloom by the trillions, the high concentrations of chlorophyll, that green pigment plants use to absorb sunlight, change the way the surface reflects light. The water may be even turn a little greenish. And so scientists use satellite observations to measure these changes in ocean color, to estimate chlorophyll concentrations, and thus the amount of the algae in the ocean. So more chlorophyll or higher chlorophyll concentrations equate to more algae. Less chlorophyll would represent less algae. And so again, we're looking at kind of the why has primary productivity, or why has the amount of food in the Arctic changed over time. And this is one of the visuals, and I'll add a link to the chat here in just a moment, that we want students to spend some time looking at. And it's the relationship between changes in Arctic sea ice on the left and changes in chlorophyll concentrations on the right. And so the red, we'll focus on the Arctic sea ice here. In the red, this is showing reduced sea ice, so a loss of sea ice. Blue would represent the growth of sea ice, more sea ice in those particular areas. And so you can see there are certain areas in the Arctic that are experiencing increased sea ice loss. If you look at the chlorophyll A concentrations, green and darker green represents high concentrations of chlorophyll, more food. The browns, the tans and browns would be lower chlorophyll, less food. And one thing that might jump out at you maybe, and maybe your students, is you can see where we see this loss of sea ice, we also see an increase in chlorophyll A concentrations. And so with your students, when you present this, this is more of a classroom discussion that you'd facilitate with students, describing the graphic, having students talk about, answer these prompts with a partner, maybe sharing out some ideas. But, you know, hopefully they're looking and seeing that sometimes you see a reduction of sea ice associated with an increase in chlorophyll A. How might you explain these patterns? So challenging students to look at these visuals, identify patterns, and try to come up with some explanations. And the hope here is that they're kind of drawing on that photosynthesis investigation and thinking about how a loss of sea ice, with less sea ice, more sunlight can reach the ocean surface, right? We know sunlight is important in photosynthesis. More sunlight, more photosynthesis, more food is available, more higher chlorophyll A concentrations. That is the purpose of this particular visual. I have the slide hidden. I offer it as an extension in the curriculum, but we can go here now. There's also some satellite imagery that looks at the relationship between sea ice and absorbed solar radiation. The blue on the left, this is sea ice fraction, less sea ice in blues, more sea ice in reds. So you can see significant sea ice loss in the Arctic. And then this is absorbed solar radiation. So again, the amount of solar energy absorbed at the surface. You can see a pretty clear relationship between where sea ice is lost and where we're seeing more solar energy absorbed. And so you, as the facilitator here, you're really trying to make the connection between sea ice loss and increasing the food availability in terms of the ability of algae to photosynthesize, make more food. Now, these satellites are only measuring ocean algae, pelagic algae exposed at the surface. And so what we're seeing here is that ocean algae populations are increasing with declining sea ice. With more sunlight available, that pelagic algae, that open ocean algae, they're thriving. Scientists don't fully understand how sea ice loss will affect sea ice algae, but many predict that the population of sea ice algae will decline with that loss of habitat. So what we know for sure is that there's more food available from these ocean algae. They're thriving in these changing conditions. What we don't fully understand is how declining sea ice will affect sea ice algae, but many predict that sea ice algae will suffer in these changing conditions.
Can I ask a question real quick?
Yeah.
So on your previous slide that shows well, all right, that one there. So what one of my kids would probably point out is, hey, that's the same footprint pattern on each side. So they aren't seeing any ice melting. Just visually, there's not a change in like the little things that go off in the edge and stuff. Is that just because that's the one? Like your next photo that you do does show some shrinkage or change, I think.
Like outside here?
Yeah, you like your perimeters or whatever. And maybe not so much as what I thought just a minute ago, trying to glance at brief. But that's the only thing, not that that makes a difference, and it would only be a select few that would, but you know, that might be something in the teacher thing, is if the students point out they don't see a change in that sea ice, you may say, well, from space you aren't seeing, you know, that might be a mile of sea ice and you just don't get much of a change on your patterns that you're seeing up above. So, you know, when we were talking temperature and thermal, you could see that. But now that we're talking algae, and I'm not saying you're wrong, I'm just saying, why is it still the same?
Oh, totally. And I thought, Lynn, I'm trying to would you hop on, Lynn, and kind of synthesize your comment in the chat?
Yeah, I was just responding to Shannon's question about, you know, what temperature or time of year affect this. And, you know, definitely, and this is actually kind of a cool, what I think would be a cool teachable moment, because if you've ever talked about the Arctic with your kids, or if you haven't, you could kind of take a side, you know, little track and say like, well, let's look at the differences in sunlight in between, you know, the seasons. And if you look, there's like no sunlight at all in the Arctic in the winter. And so you can therefore conclude that photosynthesis is going to look a lot different in the Arctic in the winter than the summer. So that's a great question. I kind of hope it comes up for your students, because you can really, you know, look at the Arctic is the most extreme example of that, right? So it's kind of a cool thing to explore.
Cool. I forgot about dark.
No, thanks, Shannon, for bringing it up. And I think there's a lot to kind of to explore with these, and in the teacher guides. So I will have the links that will take you to where I pulled these visuals. The reason that I don't necessarily want to send students to those websites is because the answers are given there. And so it's for that reason that I've screenshotted these and put them side by side and tasked them with trying to identify patterns and talk through how you might explain those patterns. So for this lesson, you know, a couple big takeaways, right? One really important piece here is that when we're talking about primary productivity or the amount of food increasing over time, we're only talking about ocean algae. That's what these satellites are measuring. Again, we don't fully know what's going on with sea ice algae, but many predict that we might see a decline in sea ice algae. A couple of other points, right? We talked about the importance of sunlight in terms of contributing to the rise in ocean algae populations. We also observed carbon being taken in by these aquatic plants, the base of the food web. So some important things have come out of this. If we go to our summary table, ask students to consider what they learned about declining sea ice and the impact on algae in the Arctic, and then relate it back to our unit driving question. You know, we'd hope that students would come up with something like, you know, declining sea ice is leading to an increase in ocean algae. Scientists predict declining sea ice will lead to a decrease in sea ice algae. And thinking about the unit driving question, Arctic organisms that depend on ocean algae may do better in the future if there's more food. Arctic organisms that depend on sea ice algae may suffer in the future with less food. So again, trying to bring them back with this summary table. And I think this particular lesson in particular, or I guess this lesson has some facilitation strategies, and you'd really, before you facilitate this, would want to consider, you know, where you're trying to go with this lesson. You know, there's that investigation at the start. You really want to pull out the importance of light. You really want to emphasize carbon going into the plant. And then with those visualizations, you really want to emphasize that we're only looking at ocean algae. And that's what we're seeing increasing. Now, with this lesson, I want to take a quick break, but also offer, this is an optional, you know, I know many of you may do homework, maybe many of you may not do homework, maybe this is an in-class activity, but in this lesson, all about that base, there's also kind of an extension activity where, you know, you get students thinking about these vocabulary terms again, about arrows, about how changes in the amount of algae might impact different organisms. And then, you know, whether it even matters, right? Which primary producer, ocean algae or sea ice algae, is more important to the Arctic food web? Does it even matter if there's less sea ice algae? So we'll give us a 5-minute break. When we come back, we'll dive into the last lesson and figure out if it matters if sea ice algae is potentially declining. So I invite you to take a look at that assignment. Get up, stretch your legs, and we'll finish up here after the break. So with that, going to dive into lesson 4, which will be the last lesson that we engage with today. And so in this lesson, we're tracing the flow of carbon through the Arctic food web, largely to figure out like what if sea ice algae is important in the Arctic food web, if ocean algae is more important, if it even matters that, you know, we might see less sea ice algae and more ocean algae. And so we're going to watch a video to understand some field methods in terms of how scientists are able to gather tissue samples and measure the carbon within these tissue samples of different organisms and what they do with those results. There's some construction of pie charts to determine whether sea ice algae or ocean algae, which producer is more important to the Arctic food web. And so we'll try to bring it all together with this particular lesson. If we kind of take a step back, the previous lesson, we observed evidence of algae doing photosynthesis. That was that color change as the algae removing carbon dioxide to make food. Ocean algae populations are increasing with declining sea ice, and scientists are predicting a decline in sea ice algae with less sea ice loss of habitat. And so today's lesson, we're trying to figure out which producer is more important to the Arctic food web, or to which organisms in the Arctic food web. And so this unit starts with the question, what does someone mean when they say, you are what you eat? And there's a little video here that would be optional for you to share with your students, but it would be interesting to hear what students would have to say here. Maybe you reference the nutrition facts labels on food, the fact that you're getting carbohydrates, proteins, different vitamins and minerals from the food you eat. And so that's going into your body, and that's what you're more or less made of. I tried to bring in another example to follow that, thinking about diet and different diseases related to diet. And dietary fats are really important to your health. They give you energy and absorb different vitamins, but some types of fats increase your risk of having different diseases. Saturated fats, for example, are a leading cause of, or lead to heart disease, a leading cause of death globally. And a lot of heart disease deaths are linked back to food choices and what types of fats you eat. And so I give some examples of saturated and unsaturated fats, and just kind of a scenario where it's like, my doctor says I'm on my way to having heart disease. I wonder what I could do differently. And so trying to encourage students to think, well, they could eat fewer saturated fats. Like they could change their diet. You are what you eat, right? So just trying to then make that connection, you are what you eat. Here's a human example to what's going on in the Arctic, and how scientists are able, using that same idea, you are what you eat, to trace carbon-based fats through the Arctic food web. It turns out ocean algae and sea ice algae produce different types of fats. And so while both ocean algae and sea ice algae produce food through photosynthesis, the food they produce can be converted into different types of carbon-based fats. So if scientists could trace these different fats through the Arctic food web, right, the type and relative amount, they might be able to determine which organisms rely more on ocean algae and which rely more on sea ice algae. And so here's kind of an example up here. We've got some ocean algae, some sea ice algae. This is the carbon-based fat molecule these scientists are able to measure. And you can see here's like a cope of a zooplankton, and they eat both sea ice algae and ocean algae. But which one do they eat more of? Are they eating more ocean algae? Are they eating more sea ice algae? What could scientists do to figure this out? And so, you know, hopefully you're helping students come to this idea, you are what you eat. if these zooplankton eat more ocean algae, they're going to have more carbon-based fat from ocean algae. If they eat more sea ice algae, they're going to have a higher percentage of carbon-based fat from sea ice algae. And so by measuring the different amounts and types of this carbon-based fat in different organisms in the food web, we can determine which is potentially more important to certain organisms. And
What
so
I would do real quick,
Yeah,
what I
Shannon.
would do with that slide is I would make your algae or your zooplankton 2 different colors. So coming from one is like a blue and the other's a red. And so which is the whale made up of blue or more red
Cool.
algae right in
Cool.
there? Because that'll make a better visual for the kids. Is
Great
it going to be
suggestion.
this or that?
Great. And then they could be
And then
like
a question mark.
predict
Yeah.
which these copepod, these zooplankton are they eating more? Great suggestion. Yeah, I spent a lot of time trying to figure out how to communicate this. This is really important to just test it out and have other people think about it. Thanks, Shannon. I like that idea. So in 2008, scientists, they did this. They measured the amount and type of carbon-based fats in a variety of different Arctic organisms outside of Barrow, Alaska, shown here by this red point. And from these results, scientists were able to determine which organisms rely on carbon-based fats from sea ice algae, and which is important which is important given the fact that sea ice algae populations may decline in the future. And so I wanted to stop here and just show a quick 3-4 minute video that describes this carbon tracing in a little bit more detail. Yes, Katie, I will add the scientific papers from which these results came from to the individual teacher guides, and I'll add them to the Padlet as well, so you can read a little bit more about these. So I'm going to play this video real quick. We'll see what y'all think.
Snacks, ice scoop or duct tape toolkit.
Cases packed? Check. Sled loaded? Check. Thermal pants on? Check. For this team of marine ecologists, it's time to hit the ice, and that means gunning it. It may be late spring, but it's a frigid ride out onto the sea ice off Barrow, Alaska. Desolate as it looks, the ice is actually teeming with life. With support from the National Science Foundation, Craig Aumack with Columbia University and a team have come here to study algae, microscopic aquatic organisms that form the very base of the marine food web. Some even live in the ice itself, dormant all winter until the spring sunshine kickstarts a growth cycle.
They start to bloom, which implies that they are multiplying at an exponential rate. And then as the snow completely melts and they start getting lots and lots of light, they migrate down to the bottom of the ice and then eventually leave the ice into the water column.
Algae may not seem as sexy as, say, polar bears, but without the algae, nothing could live here.
We are trying to trace the algae that grow within the ice to the underlying marine systems. So what organisms are grazing on it? Do they prefer it over algae that grow in the water column? And then how much do the organisms that live on the seafloor graze the algae once it's there?
They drill ice cores to measure algae levels and collect tiny algae eaters like these from the water and underlying mud. They drop underwater cameras down under the ice.
Jelly!
On the day we were there,
Jelly!
they netted this jellyfish. They'd seen them before with their cameras, but this is the first one they've hauled up from under the ice.
So it was like, wow, our jellyfish even adapted to swim so close to the bottom and drag their oral tentacles because they're feeding on the algae that collect along the bottom during this time of year.
Back in the lab, they run tests to see what kinds of algae the critters harvested on the ice have been eating. Going forward, the changing climate could mean less snow cover on the ice earlier in the spring, and that could mean disruptions to the food chain's delicate balance.
If you have a year when there's not very much snow, then there'll be more light early on, you'll get an early bloom.
Marine biologist Andy Jewell has done field work in Alaska since 2005. He says climate change likely will alter this habitat in ways we can't predict.
Large marine animals, seals and beluga whales and bowhead whales, the polar bears, all of those organisms are here because it is an incredibly productive environment. Typically, there's a long line of connections until you get to big animals. The entire food chain ultimately rests upon the algae.
Almack says the algae could be considered a canary in the coal mine for climate change in the Arctic, early sentinels of a changing ecosystem. So buckle up, we might be in for a wild ride.
Cool. So, that video intended to kind of supplement the research background, making the connection between you are what you eat, and talking about that modification Shannon just made, helping students kind of predict, what copepod, were they eating more ocean algae, sea ice algae? How could you tell based on the colors that are there? And this video kind of showing that, this is an active area of research, and folks are doing this right now. With climate change, with declining sea ice, we need to see the relative importance of ocean and sea ice algae and be able to predict how that might affect other other organisms in the food web. And so here is an example of a data table your students would get following that kind of introduction, where we're looking at Arctic organisms, the percentage of carbon produced by sea ice algae, percentage of carbon produced by ocean algae. And so the relative proportion of each: carbon from sea ice, carbon from ocean, in different organisms. So sea ice algae, they're getting they're making their own food. They're making that particular carbon-based fat. Ocean algae, all their carbons coming from ocean algae. And zooplankton are highly variable. So I didn't include them in the graphic that I'll show you. It's really important for students to know it's highly variable. Some of them live more in open water, and so they're getting more carbon from ocean algae. Some of them, their habitat is more closely related to the sea ice, so they're getting more, upwards of 90% of their carbon from sea ice algae. And so that's highly variable. And then we have some data from polar cod, ringed seals, bowhead whales, and polar bears. And again, we're focused on that one region in northern Alaska. Know that this might be different depending on where you are in the Arctic. And so what students would be tasked with doing then is constructing a series of pie charts using these data sets to determine the relative importance of sea ice algae and ocean algae. And I'll show you what I mean here in just a moment. So what students would be doing in this lesson is referring to that table, tracing the flow of carbon-based fats, ocean versus sea ice algae through the Arctic food web. They're constructing these different pie charts and answering some analysis questions. I'll show you an example right now. So students are going to get this worksheet here, right? And so it's got a series of circles. That's where they'll construct their pie charts. They'll need to have a color or some sort of texture represent carbon from sea ice, carbon from ocean algae. And so I've just kind of started this for us here today. Again, given the amount of time we have, we're not going to be constructing these pie charts together. But you can see ocean algae, 100% of carbon produced by ocean algae. That's what they're made up of. Sea ice algae, 100% of the carbon produced by sea ice algae is represented here. Copepods or zooplankton, lots of different kinds. And so I don't have a pie chart there. Students are going to look at that data table. And for bowhead whales, right, you can see they're getting more carbon from ocean algae than sea ice algae. These polar cod, you can see they're getting more carbon from sea ice algae than they are from ocean algae. Seals, more from sea ice algae than ocean algae. And polar bears, more from sea ice algae than ocean algae. And so, students are constructing these pie charts and then asked a series of analysis questions similar to what I'm going to pose at the top of the screen here. Which animals are getting more of their carbon from sea ice algae, right? And so you can point to polar cod, seals, these polar bears, right? And so if we think about which animals which animals get more of their carbon from sea ice algae, again, we can kind of see how that carbon is moving through when we add this particular food chain, overlay this particular food chain. So in the student worksheet, students are asked to interpret these pie charts to construct a food chain that shows which organisms are more reliant or more dependent upon sea ice algae. And then they're asked to consider, well, how might a decline in sea ice algae affect these organisms, right? If these organisms are dependent upon this carbon-based fat derived from sea ice algae, if we have less sea ice algae, these organisms, something's going to have to change, right? They're either going to have to change their diet. It's going to have to become more dependent upon a food chain tied to ocean algae, or they're going to see their populations decline or have to migrate elsewhere. If we think about carbon from ocean algae, right? Bowhead whales in this example are getting more of their carbon from ocean algae. And so you can see they're more reliant on this particular food chain. If we have an increase in ocean algae, right, we might expect to see certain zooplankton do better, have more food available for bowhead whales. And so it's really important here to the reason that I chose these specific organisms. One, they're included in that case study, but two, it doesn't show that all organisms are going to be affected the same way, right? Some might do better, some might do worse. And it's through this tracing of carbon through the food web that we're able to make these predictions. And so what you would do next is you would go challenge students. You'd review those questions as they relate to those pie charts as a class, and then, complete this summary table, and what we learned, students or scientists can trace carbon-based fats through the Arctic food web to determine which producer they are more dependent upon. And how it relates to the unit driving question. Arctic organisms depending upon sea ice algae may struggle to survive in a future with less sea ice algae. Less sea ice, less habitat. And so struggle to survive or have to adapt in different ways. Organisms dependent upon ocean algae may thrive in a future with more ocean algae, less sea ice, more sunlight, more food, more productivity. And so again, the purpose here is to trace the flow of carbon through the Arctic food web. We saw how carbon gets into these algae, these plants, in the photosynthesis investigation. And now we're able to trace the flow of the carbon through the Arctic food web and use that data to make predictions about changes to the rest of the Arctic food web. So with that, after that particular lesson, lesson 5, putting pieces together for those of you that have engaged in different curricula with me, this lesson is all about asking a series of questions that help students put the pieces of the puzzle together and tell this story. And so we won't have time to do this today, but know that, in the student worksheet for lesson 4, you can see those questions. And this is that's not the right lesson, lesson 5. So these questions are available here, starting about how sea ice has changed over time, how organisms are connected, how the decline in sea ice has affected ocean algae and sea ice algae, how scientists trace and determine whether the diet of Arctic organisms depends on one algae more than the other, and then, kind of helping them put that all together. And I realized I'm doing this a disservice by moving more quickly. So this is just a good experience for me, but I can see there are lots of good things in the chat. And Mr. Fairley's asking about algae derived from the same study. And yes, the exception being polar bears. And so I'll add the two studies. So all of those numbers came from one study except for polar bears. So it all is consistent within the same animals within the same region. And so after students, you finish that particular lesson, you put them in groups, have them answer these synthesis questions together, helping run a thread through each of the lessons. The final assignments here are a final model construction. They're constructing a model to explain how declining sea ice might affect Arctic organisms, large and small. And so they're doing this in pairs, and I would expect this to look very different than their first attempt, right? So we've got this background image, these cutouts, and we're hoping that students are able to talk about the flow of carbon through the food web and using that as evidence when they make their predictions for this unit driving question. Another final assignment, students construct those final models in pairs, but a final written explanation individually. And so again, each student, when they construct their final explanation, they can use any resources, summary tables, public records. They can look at their final model, use that as a reference, use anything that they've developed or that we've created as a class throughout the unit when they construct this final explanation. So the whirlwind of this, basically, here's the deal. That's the end of the workshop. And I know that felt really abrupt and, at least for me, a little unsatisfying at the end there. However, I really appreciate you being here, and hopefully you were able to kind of make the connection between each of the lessons and connect the dots and tell a story here. The story being declining sea ice and its impact on the Arctic food web. It's complex, and scientists are tracing the flow of carbon through the Arctic food web to make these predictions. I know that I modified this from 2 days to 1 day, and with that, I'm no longer offering a credit for this course, but do want to offer those of you that are interested, I want to provide you with a 4-hour professional development certificate for your time. And if you want that professional development certificate, I would ask that you complete an exit ticket. More or less, it's your name, your email, basically what you liked and didn't like about the workshop. And then if you're interested in piloting the curriculum, or if you're interested in getting materials purchased for you, you would make that suggestion. Oh no. Oh no. All right. Let's do this right now. Exit ticket going in there. Need to update that. Save. What about now, folks? Yes. All right, cool. So that exit ticket, name, email, how you might use it, a question you still have. Are you interested in piloting? If you select yes, I'm going to reach out to you about that. It's a $200 stipend for piloting this curriculum. If you plan to implement parts or all of this unit, let me know. I want to get in touch with you about ordering supplies. And if you would like a PD certificate. Oh, and then the other option here, if you want a 6-hour professional development certificate, what you need to do is complete 2 final assignments, a final model and a final explanation like your students would. Those assignments are in the Padlet and would be submitted through a Google form. So if you've taken a workshop with me before, you know what those assignments look like and how to submit them. So if you want a 4-hour PD certificate and that's all you want, please complete this exit ticket, submit it, and you won't hear from me unless you are interested in piloting or having materials purchased for you. If you want a 6-hour certificate, please complete the final assignments, which are a final model and written explanation. Those instructions are here in the Padlet. And once you submit those, I'll give you a 6-hour PD certificate. And then now it's 4 o'clock. 4 hours is just the survey, right? Yep. If you want the 4-hour PD certificate, complete that survey. And I'll reach out with a PD certificate. And I'm also really 6 hours is the other stuff too. Yep. So I anticipate this final model and written explanation taking maybe another hour, but would give you a 6-hour PD certificate if you complete both of these assignments. If your head's going to explode and you want to just email me about this later, please, you got my contact information here. And also, last but not least, there's plenty of other curricula that follows this model-based inquiry framework. This Arctic feedbacks unit, a future of forests unit looking at post-fire landscape recovery patterns, and this data puzzles resource that Lynn and I are actively working on. So definitely a whirlwind. I'm definitely happy to hang out and chat more for those of you that have questions. For those of you that want to sign up, please do. Thank you so much for being here. I apologize for the chaos that was the end of that workshop, but look forward to working with you all in the future. Thanks all. Hang out if you want to ask questions or would like clarification. If not, keep in touch. Have a great start to the school year.